Good evening, this is Mr. Wintermelon. So we have come to the last lesson of our excretion, where we will learn about kidney failure. So here you can see the TT Tulan down here with his golden tab, because he's a failure. But what we are going to focus on will be what the syllabus expects us to know, which is the mechanism of dialysis in case of kidney failure. But as a biology student, this one is just for your information as to why your kidney might stop functioning. So some common risk factors include high blood pressure, diabetes, alcohol abuse, or you get into an accident whereby you severely injured your kidney, or you have some operation which affected your kidney. So in this event, what will happen is your body will not be able to excrete urea. So urea will be retained and it will cause poisoning. The pH of your blood will also decrease, and when it's lower pH, that means it's more acidic. You will also have problem regulating the water potential in your blood, causing high blood pressure. So a very good option will be kidney transplant. So kidney transplant can be highly successful. What happened during a kidney transplant is, I know there are two penis down there, but let's not focus on the penis, let's focus on the kidney. So you have a donor with two healthy kidney. You can remove one of his kidney or her kidney and surgically transplant it into the recipient. So the recipient will end up with 3 kidney. Then you might be worried, wouldn't the donor have issue because now he's left with 1 kidney? It is okay because a person can live a healthy life with just 1 kidney. So normally someone with malfunctioning kidney, right, both of the kidney is spoiled. So it requires a kidney transplant. But the problem is you do not have kidney running around, and even if you have kidney running around, not every kidney is suitable for everyone. Because there is tissue rejection. Remember the chapter on transport in human, whereby we talk about white blood cell as well as white blood cell causing tissue rejection. So if you have a kidney that is not compatible, what will happen is your white blood cell will try to destroy the foreign tissue, which is the kidney that you are given. So while waiting for the doctor to find a suitable kidney, the doctor will most likely advise the patient to go for dialysis, because as you have learned earlier, a patient might not be able to survive more than 2 weeks without proper treatment. So this is a dialysis machine. Basically, it is a kidney but in machine form. So you can see our kidney is actually quite small compared to this large chunk of a machine. So what this dialysis machine does is what both our kidney are doing right now, which is filtering our blood. What does it filter for? It filters out our metabolic waste such as urea. So just a brief outline of how it works. Blood is drawn from fistulated vein. What is fistulated? Basically, before a patient can undergo dialysis treatment, what the doctor will do is to have a minor operation whereby he connects the artery of the patient to the vein. So this procedure will form a fistulated vein. What will happen is, since the artery is connected to the vein, it will allow the vein to have a greater blood pressure. Why we do not want to just draw out blood from the artery is because the pressure is too high. So we draw it out from the vein, but at the same time, the pressure is too low. So we need a bit of help from the artery so that it will reduce the time for the patient to undergo dialysis because the blood can flow through the dialysis machine at a shorter amount of time. So after the blood enters the dialysis machine, it will go into the dialysis membrane. So this dialysis membrane is partially permeable and it will keep the blood as well as dialysis fluid separated. Our blood cell as well as large molecules will remain in the tubing because they are too large to diffuse out. Metabolic waste such as urea will diffuse out from the blood because there's a concentration difference between the urea in our blood as well as the urea concentration in the dialysis fluid. There will be no net movement of nutrient molecules such as our glucose because the concentration of nutrients inside the dialysis fluid is the same as the concentration of nutrient inside a healthy human blood. So after the urea have been filtered out, the blood will return to the patient bed. So this is just a brief outline. You can copy down this simple version. But why not copy down the animated version? What I have down here is an animated dialysis machine. You will probably want to copy down notes from this animation. As you can see, the dialysis tubing is coiling around the dialysis machine. This will increase the surface area for the diffusion of urea out from the blood to take place. So blood is drawn from our fistulated vein and is being pumped into the dialysis membrane. So the dialysis fluid will enter the dialysis machine from the opposite end of the machine. So you can see the blood enter from the top while the dialysis fluid will enter from the bottom. This is very important and very smart. You will see why later on. The concentration of glucose, amino acid, as well as mineral salt in the dialysis fluid is the same as that of a healthy person's blood. And the dialysis fluid contains no metabolic waste such as urea. So this will help to set up a nice steep concentration gradient for diffusion of urea to take place. So the dialysis fluid will exit through the top because it is flowing in the opposite direction of the blood. The blood will go in from the top and exit through the bottom, while the fluid will go in from the bottom and exit through the top. And this is very important. Our dialysis membrane is partially permeable, so this will help to keep the blood as well as the dialysis fluid separated. Our red blood cell as well as white blood cell will remain inside the dialysis membrane because they are too large to diffuse across. Then large molecules such as protein will also remain inside the tubing. This is similar to what is happening inside our glomerulus, whereby the protein are not filtered out. So over here, I have two molecules. The green molecules is used to represent glucose, while the yellow molecules is used to represent urea. Why? Because if I say urine what color, you will tell me yellow. So yellow molecules is the urea. So what will happen is the metabolic waste such as urea will diffuse out from the blood because there is a difference in concentration of urea in the blood as compared to the dialysis fluid. There will be no net movement of nutrient molecules such as glucose because the concentration of nutrients inside the blood is the same as the concentration of nutrients in the dialysis fluid. So as the molecules travel through the membrane, the concentration of urea will decrease. When it reaches the end, the concentration of urea will be very low already. But it doesn't matter because remember, when it reaches the end is the start or the beginning where the dialysis fluid flows in. And when the dialysis fluid flows in, it actually contains no urea at all. So there will still be a concentration gradient of urea in the blood as well as the dialysis fluid. Therefore, this opposite direction will ensure that there will be a difference in concentration gradient of urea from the start to the end. So at the end, you can see that the urea concentration is low, but the dialysis fluid urea concentration is like non-existent. Whereas the dialysis fluid will gain in concentration of urea as it is flowing towards the exit. So when it reaches the exit of the dialysis fluid, right, the concentration of urea will be higher already because it is receiving urea as it flows up. But it doesn't matter because remember at the start, the concentration of urea in the blood is high. So at the start, since the concentration of urea in the blood is high, it doesn't matter if the dialysis fluid have a bit of the urea because the concentration of urea in the blood will still be higher in the blood as compared to the concentration of urea inside the dialysis fluid. So diffusion will still take place in the end. And the same is true when it reaches the ending. Even though the concentration of urea in the blood have become more diluted, but at the end is the start of the dialysis fluid, whereby there's no concentration of urea. Therefore, the concentration gradient of urea between the blood and dialysis fluid is still maintained. So after that, the blood will return to the patient vein. So just to sum up the feature of a dialysis machine, please take out your notebook and copy this down as well. So some of the features: the concentration of the nutrients in the dialysis fluid is similar to that of a healthy blood. So this is to ensure there's no net movement of nutrients molecules. Dialysis fluid also does not contain any metabolic waste such as urea. So this is to set up a steep concentration gradient for waste to diffuse out. The dialysis membrane is partially permeable. So this dialysis machine is something like a Bisking tubing. It will allow small molecules to pass through while our blood cell as well as large molecules will remain in the tubing. The tubing is long, narrow and coiled. So this will increase surface area to volume ratio to increase the rate of diffusion. And lastly, something that I have kept on mentioning, the direction of blood flow is opposite that of the dialysis fluid, and this is to help to maintain the concentration gradient between the urea inside the blood as well as the urea inside the dialysis fluid. So that will be all for the mechanism of kidney dialysis.